If the last Java you wrote had a getter, a setter, and a 50-line builder, I have bad news. That language is gone. Modern Java does not look like Java anymore. No boilerplate, no null checks everywhere, no thread pools. In the next 8 minutes, I'm showing you 10 features that turn Java into a language you'd actually pick on purpose. And every one of them ships in the JDK you already have installed. 10 changes, no frameworks, no libraries, no Lombok. Just the standard library and syntax that already exists in Java 21 and later. If your mental model of Java is stuck somewhere around version 8, this is the upgrade. Let's go. Number 1. var, local type inference. Old Java made you say the type twice. Map of string to list of order, orders, equals, new hash map of string to list of order. 40 characters of ceremony to declare one variable. With var, you write var orders equals new hash map of string to list of order. The compiler infers the left side from the right side. This is still 100% statically typed. Var is not JavaScript's var. There's no dynamic typing here. The type is fixed at compile time. The rule seniors use. Var when the right-hand side already names the type. Explicit types when it doesn't. Your code gets shorter without getting vaguer. Number 2. Text blocks. Java's most hated thing was multi-line strings. A 10-line SQL query became a wall of plus signs, backslash, and escapes, and escaped quotes. Nobody could read it, and everybody broke it. Text blocks fix it with 3 double quotes. Open with triple quote, write your SQL or JSON exactly as it looks, close with triple quote. No escaping, no concatenation, and the compiler strips the common leading whitespace so your indentation doesn't leak into the string. There's a formatted method for interpolation and a backslash at end of line to join lines. Every JSON fixture and every query in your test suite just got readable. Number 3. Records. This is the one that deletes whole files. A data class in old Java was a private final field, a constructor, a getter, equals, hash code, and to string. 60 lines for 3 pieces of data, or a Lombok annotation, and a build plugin. Now it's 1 line. Record order, open parent, string ID, comma, big decimal total, close parent. That's it. You get an immutable class, a canonical constructor, accessors, correct equals and hash code, and a readable toString for free. Add a compact constructor if you need validation. Records are shallowly immutable and final by design. They're data, not objects with behavior, and that constraint is exactly what makes them safe. Number 4, switch expressions. Old switch was a statement. It returned nothing. It fell through if you forgot break, and you had to declare the result variable before it and mutate it inside. Every code review had a missing break bug. The new switch is an expression, arrow labels, no fall through, and it returns a value you can assign directly. Comma-separated labels replace stacked cases. If you need a block, use yield. And when you switch over an enum or a sealed type, the compiler enforces exhaustiveness. Add a new enum constant, and every switch that doesn't handle it fails to compile. That's a whole class of production bug that just stops existing. Number 5, sealed interfaces and pattern matching. Together, these are the biggest shift in how Java models a domain. Sealed interface payment permits card, bank, wallet. Now the compiler knows the complete set of subtypes. Nobody outside your file can add a 4th. Then you switch on the payment and match patterns directly. Case card, arrow, use card dot, last 4. No instance of, no cast, no visitor pattern. Add record deconstruction and you go 1 level deeper. Case card of parent, string number, comma, in expiry, close parent, and you have the fields destructured in the case label itself. This is algebraic data types in Java, and it makes illegal states unrepresentable. Number 6, optional used correctly. Most code bases got this wrong. They call optional.get and wrap it in an if present check, which is just a null check with extra steps and worse performance. Optional pays off when you chain it. Find the user, map to their address, map to the city, filter out blanks, or else return unknown. One expression, no branching, and nothing can throw a null pointer in the middle. The rules, return optional from methods that legitimately might not find something. Never take optional as a parameter. Never put it in a field, and never call get without an or else. Use that way, whole categories of null pointer exceptions disappear. Number 7. Streams the modern way. Streams have been around since Java 8, but the way seniors write them changed. Collectors dot to list is dead. There's a toList method on stream itself now, and it returns an immutable list. Collectors dot grouping by turns a for loop with a map and a get or default into one line. Map multi and take while and drop while replaced a pile of manual index juggling. And the rule that matters most, a stream should read like a sentence, filter, map, collect. If your stream is 9 chained operations with a nested lambda, that's not clever, that's a for loop wearing a costume. Extract it to a name method. Number 8, the built-in HTTP client. If you're still writing HTTP URL connection or pulling in Apache HTTP client just to make one GET request, stop. The JDK has had a modern client since Java 11. HTTP client.new HTTP client. Build a request with a URI, send it, read the body. It speaks HTTP 2 by default. It handles redirects and timeouts as first-class options, and it has an async API that returns a completable future. No dependency, no shading conflicts, no CVE in a transitive library you forgot you had. One less thing in your POM file, and it's faster than the thing you replaced. Number 9, virtual threads. This is the headline feature and the one that changes architecture. Platform threads are expensive, about a megabyte of stack each, so you pool them, you tune the pool size, and you tell everyone never to block. Virtual threads cost a few hundred bytes. You can run 1,000,000 of them. Executors.new virtual thread per task executor. Submit one task per request and write plain blocking code. A blocking call parks the virtual thread and frees the carrier thread underneath. That means you get the throughput of reactive programming with the readability of synchronous code. No flat map chains, no reactive debugging, and stack traces that actually make sense again. Number 10, the tooling nobody tells you about. You can run a single file directly, Java space app.java. No javac, no class path, no build tool. Since Java 22, that file can even import other source files, so a real script is one command. There's jshell, a proper REPL, for testing an expression in 3 seconds instead of writing a throwaway main. jpackage builds a native installer, and jlink strips the JDK down to only the modules your app uses, which is how you get a Java container image under 100 megabytes. And instance main methods mean hello world is now 4 lines with no public static void. Put those 10 together and look at what's left. No getters, no builders, no null checks scattered through the call stack, no thread pool tuning, no HTTP dependency, a domain modeled with records and sealed types where the compiler catches the case you forgot. This is the same JVM you already trust. The same performance, the same tooling, the same libraries with 20 years of ceremony removed. Java didn't get replaced. It caught up, and then some. If this was your first look at modern Java, do one thing today. Open one data class in your codebase and turn it into a record. Watch 60 lines become 1. Then drop a comment telling me which of these 10 you'd adopt first. I'm betting it's virtual threads. Subscribe for more, and I'll see you in the next one.